Good morning, everyone. Well, morning from out here on the West Coast. Welcome to the Javelin webinar of Solidworks 3D CAD, and we're going to be talking today about how it's offering increased value to 2D designers, specifically talking about sheet metal. So let's do a quick introduction. My name is Angus Hudson. I'm an application engineer here at Javelin Technologies, based on the West Coast in our Vancouver, BC office. And so Javelin Technologies has 6 offices across the country, and our head office is located in Oakville, Ontario. We have over 100 people and hundreds of certifications to make sure that we are the experts in what we do. We were founded in 1997. We just celebrated our 28th anniversary, and that means that we have quite a bit of experience in helping people find the right solutions. At Javelin, we view the product lifecycle with all of these different things contributing towards getting high-quality product out the door. So that's people, technology, process, and manufacturing. And we have solutions to enhance every stage of this track. We know that people are your competitive advantage, and trusting and investing in your people ensures you get the most out of your investment, specifically the investment in technology. As far as technology, we know that it encompasses the tools that we use to create incredible designs. And we strive to help you find the technology that will increase your productivity and to find solutions that work for you. So since the beginning, Solidworks has grown from a small 3D mechanical design program into a full innovation platform. There's technology to assist with all aspects from concept and the 3D experience software through the design and validation stages with the CAD, electrical, and simulation, into processes with product data management, and then into manufacturing with technical communication and MBD. At Javelin, we also have many partner products which can help you achieve your goals and give you just extra functionality out of the software. At Javelin, we love to standardize and automate common processes in order to reduce the burden on users and increase the quality output. Our PDM services can be tailored to whatever your individual needs are. We know that manufacturing is the goal of this entire thing because that's how you get your product out the door. We have solutions to help you move from 2D drawings into 3D, produce CNC code, as well as things like 3D printing. So now we're going to talk about the solution. Let's get to our solution demonstration. We're going to be talking about SolidWorks 2017. And what 2017 does, what SolidWorks does, is let us do several things, such as leverage our legacy data, so we can use previous files that we have to create new parts. It lets us design, fit, and function in context around the parts that we have. And it also lets us modify our existing processes to switch parts between machined and sheet metal processing, manufacturing. And so what these do is, this is the advantage of working in 3D, it's the advantage of working with SolidWorks. So let's get straight to it. Let's talk about using SolidWorks to leverage legacy data. So for this, we're going to open up SolidWorks, and I have a DXF that I created. And so it's the flat pattern of a part that we have. So what we're going to do is we're going to import it as a new 2D sketch. So you can see it gives me several options here. I'm going to merge any overlapping entities just in case there's a mistake, and I'm also going to run the repair sketch just to be sure that we're avoiding any errors as I do this. So you can see here the repair sketch utility let me that no problems have been found. So that's great news. We can get started with our part. And so here it is, you can see that's been imported as a sketch. And I can actually add things to this as necessary. So I'm going to add a couple of construction lines here, just so that I can find the middle of my part. And this will be helpful later on, but it's good just to know where that middle is going to be. And so what we can also do here now is we're going to escape out of our sketch, and we can see that this part is not actually on the top plane, it's on the right plane, sorry, the front plane. So it's very easy for me to go in here, just say edit sketch plane, and select the top plane as the new place for it to be. And you can see it orients accordingly. So what I'm going to do is flip to my top plane, and we're going to start making some new sketches. So the first one I'd like to do is I'd like to select this entire outline, and I'm now going to convert it into my new sketch. And you can see it shades in. SolidWorks letting me know I've got a closed contour, so I can start making a part out of this. Not going to do that quite yet, though. I'm going to make a couple more sketches here. So I'm going to make one which will be all of my cutouts. So you can see that there are quite a few things here, which I'm going to need to make into cuts. So I can just use the select chain tool on all of those. And then I can grab these circles here, because these are all going to become bunched up parts of my sheet. Sorry about that. I escaped before I was done. I have to remember to hit the Convert Entities button. So if you haven't used this before, though, the Convert Entities, it can also be used to take lines and edges and things like that from other sketches and other features. And so it's very useful when we're working in SolidWorks. There we go. We're also going to make another one here. Just convert my bend lines in. And so we just need to select all of those. And so this is just what we're doing right now. We're grasping the information that we've put in to our part, and we're telling SolidWorks what's important, what we need to keep. Good. So at that point, what we can do is we can actually start making this. So if we go over to our sheet metal tab here, we can say create a base flange. And you can see it's picked up that it's a closed contour. I'm now going to choose a gauge table. And what this gauge table allows me to do is it allows me to tell my designers, these are the different types of material that we have. Feel free to design with them. And I've already got information like my material and some of the different bend radii included in it. Then at this point, all I have to do is hit OK. And now we've got a flat sheet. At this point, just before I do anything else, I'm actually going to create a jog. And so in order to do that, I'm going to need to make another sketch. And we're going to use that Convert Entities one last time. So I'll create that. And then from there, I'll go to Sheet Metal. And I hit Jog. All I have to do is select the fixed face. And you can see it's giving me a detailed preview of it now. I'd like to flip the side. And I'm also going to say I'd like to fix the projected length because we know this is the flat pattern that we're working with. So it doesn't make sense for it to project it as the same length. And there we go. There is our jog. We started bending our part. Now we can take all of these cuts here and we can turn those into extruded cuts. Really cool feature that I've got turned on there is the link to thickness. So you can see without it here, it's doing a 10 mm cut. Or I hit link to thickness, and it now doesn't matter if I change this to be thicker sheet metal, it's automatically going to link it to that thickness. So that's very helpful, and that saves me time later on. At this point, we can say it's time for some sketch bends. And before I do that, I'm actually going to just make sure I select the correct sketch. There we go. And at this point, we just select the fixed face again, and you can see it's giving me that preview, and there we go. That is our part. So you can see in just a couple of minutes there, I was able to rapidly create this part. So yeah, it was very easy for me to go straight from that 2D sketch, that DXF, right into a 3D part. SolidWorks helped me the entire way. It was checking for the sketch for errors, and this ensures accuracy, it avoids those errors. And at this point, I can now start applying new features to my 3D part, or I can use it for other things. So next up, we're going to talk about designing for fit and function. So I've just switched over to an assembly here, and you can see that it's that same base that I created before, but now I've also added just a fill pattern here for ventilation. So this is an example of me being able to add those features very quickly. You can see though, so I have that base part, and then I have the cover. The cover is currently empty. I've just inserted a blank part into my assembly. So what this lets me do is it lets me now design in context. So I can say edit this part, and I can flip around to this face and start a sketch on it. So I'm now sketching on a face that is not actually in my part, which I always find very cool when I work with this. So we can quickly create a line there. I'm just going to flip this one to be for construction. We can start making more lines. And you can see here I'm picking up those relations between the part. And there we go. At this point, we can now start dimensioning. And we can actually dimension this directly to that part that we're designing around. So this is a really fantastic way to do top-down design. And it means that we can be assured that our parts are going to fit properly. So just like we can dimension to it, we can also add relations. So let's select this edge here, this one. That's now easy for me to make a collinear relation there. So we saw before when I had a closed contour, as I went into the sheet metal base flange tab function, it created just a sheet. Well, now we can see that it's extruding it as a thin wall feature, which is fantastic. It's already picked it up. I can come back in, use my gauge table once again to make sure that my designers aren't doing things with stuff I don't have in the shop. How often have we had that happen? So I can do that. And I'm actually going to say, I'm going to design this completely around this existing part and just say go up to that vertex there. There we go. That's our that's the beginnings of our cover here. We can now start adding some flanges to it. So I'm going to add a miter flange. And in this case, we're also going to use a bit of both parts here now. So we're going to get it right at that intersection there and come out here. And there we go. That's pretty much it. You can see the flange is shown automatically. So you can see I can actually choose where the flange is. And if I was looking at it this way, I would see, no, I'm going to have some serious problems with interference there. So this lets me just make sure that the part is going to work properly. I can do things like add an offset here. And that's going to just make it fit better around the part. And then I can also just propagate it down this edge here. If I'd like to, I could increase the size of my my miter corner there if I want. I can increase the gap. So this is great. I can create this flange very quickly. If I wanted to, I could have included another flange in there, but then I wouldn't have the opportunity to show you this great edge flange tool. So this one's really great. You just select an edge and drag it down. It's as easy as that. 12 millimeters looks about right. I can do the same things as before, picking where I'd like the flange position to be. And then I can also grab onto this one here. And again, we can see we're not going to have any problems with interference. So we can very quickly create those flanges. At this point, I've already done half my cover. I don't need to do any more work. I don't need to go through and do any more sketching. All I can do is come back here and use a good old-fashioned command. So I can select this as the face there, and then I just select the entire body. And there you go. As quickly as that, we have created our cover. So now I'm going to open this up and I'm just going to show us some of the new things we can do. So we can take it out of that in-context design and open it as we might normally. So I've just got the Go to Webinar toolbar in a very inconvenient place. I'm going to move that. So I'm going to go into my design library here. And you can see I can now start adding forming tool features. So these are just like a library feature. I can drag it on. I can position it much like I would with the whole wizard. And I can add it in just like that. Very easy to do. If I wanted to, I could move this above my mirror here. And you can see that because SolidWorks is the feature history-based modeler, it adds it to both sides, just one convenient feature. I'm actually going to roll back before that mirror. And now, what if we wanted to add a cut here, and we want it to be completely normal to our material? Well, that's also easy to do, because we can just unfold this bend, and now we can add our cut directly to it in a very convenient way. So I'll just make a quick circle here, put it on my midpoint. Doesn't really matter how big it is. And there we go. As soon as we exit, we can see it's linking to thickness once again. And there we have it. We now have our cut. We can go back to our sheet metal tab and just quickly fold this back up by saying collect all bends. And there we go. That's our part. And once again, because of the feature history-based modeling, it's now been applied to both sides of our part. So this is very convenient. So you can imagine this is a really easy way to do this. So I'm just going to skip ahead a little bit. I'm actually going to close this part down. And what I'm going to do now is I'm actually going to grab a different file that I've created for this, because what I would like to do is show you the vent feature. And the reason this vent feature is important is because it's going to really highlight one of my points later on. So as I open this part back up, you're going to see that I now actually have another sketch here. And so this sketch is what I'm going to use to make a vent. And this is, as you can imagine, this is going to be an electronics box. Sorry, I don't know if I mentioned that. It's an electronics box. And so it's going to be really helpful to have that good ventilation. So we're going to edit this part just like we did before. We can come over to sheet metal, and we're going to grab the vent. At this point, we can use these sketch entities to define the outer boundary of my vent. As soon as I define the whole thing, it shows me where it's going to make the cut. Now it's just easy to grab the other entities and start defining my ribs and my spars. I could change the size of these if I needed to, so I have quite a bit of control when I'm using this vent tool. And there we go. There is our vent. Very easy to do. So part of the reason I wanted to create this is because I want to show you an incredibly great thing about when we design in context. Beyond the fact that we're making sure that the fit and the function is going to be great, it lets us do something else. So if I come over here, back to my original sketch, I'm going to grab onto it, and I'm actually going to select the entire thing. At this point, what I'm going to do is I'm going to say scale entities. I want a 1.5 scale right about that midpoint. So normally, this could cause me a lot of problems if the parts were not linked well together. And you can see it's actually showing some errors at the moment. But as soon as I exit this, SolidWorks is going to take a quick moment to look at what I've done, and you can see it updates accordingly. So I hope this will be pretty helpful for some of you. But yeah, it's great. This automatically means if I want to make configurations that are different sizes, anything like that, that's really easy to do. This saves me a ton of time. It's really cool. It's incredibly helpful, and it's one of the main advantages, I think, of working with SolidWorks for sheet metal design. So I'm actually just going to undo all those steps because that's bigger than I would like it to be. And there we go. If we open this part back up, we can take a look here, and when we're sheet metal, we always get the option to go back to that 2D view, to that flattened shape. And so from here, all I have to do is right-click on it, and I can say export it to a DXF or a DWG. So I can export this to common file formats that I would normally use. So this is incredibly helpful. If I close this back up, I actually have a drawing previously created of this. So I'll open up this drawing just to save time, but this is really easy to create. You can see here if I open up my view palette, SolidWorks automatically gives me the option to bring in the flat pattern. It's showing that I've got that. And it color codes all of my bends. I've inserted a bend table here, which has the direction, the angle. It's got the radius on it. So all of this information is really easily given over to people. I can add dimensions of my bounding box if I'd like. And so we can see here that SolidWorks makes it very, very easy for us to create these high quality drawings. So as far as designing for fit and function, it's fantastic that we can use our existing parts to define new ones. And if we change that part that we're using to define the new one updates with it. And so this helps us ensure fit and function. It's great for if we want to make a new size of our part. It really saves us a ton of time in the long run. We can see it was really easy to add complex sheet metal features. We can add those normal cuts. We can add library features. This is all very easy to do. And because of the part definition, our designs are robust. They'll update accordingly. We don't have to go through and check all the errors and see all the different things that are breaking. It's already done for us, and SolidWorks is doing all of the thinking. We're also able to see there that we can easily create those drawings, and this is done very quickly. Just because we're working in 3D doesn't mean we don't have the ability to work in 2D. We can still very much do that. We can also export to the formats that we need. And this is a good one for me to mention Nesting Works. It's one of the great add-ins that Javelin offers, and it can really increase our efficiency and help us optimize our material usage. So whether that's for cost or for sustainability, we have a solution for that. My name is Agus Hudson. If you have any questions in the future, please don't hesitate to get in touch. And I hope to talk to you again soon. Thank you.